Hello everyone. Today we are going to discuss about acceleration and acceleration due to gravity. Here we are given a situation where there is a toy car and initially the toy car is at rest at time is equal to 0, its velocity is 0 meter per second, and as time passes the velocity of the toy car is also increasing. Now here we have considered that after every 1 second there is an increase in the speed of the car by some amount. After every 1 second, there is an increase in the speed of the car or the velocity. Since the car is moving in a straight line, the speed and the velocities are same. So there is a addition of 2 meter per second velocity from 0 to 2, and again from 2 to 4 there is an addition of 2 meter per second after 1 second. Again over here there is an increase, there is an addition of 2 meter per second after 1 second, and here also after 1 second time there is an addition of 2 meter per second. Now acceleration has a formula, that is A is equal to V minus U by T. V is called final velocity, U is initial velocity, and velocity is measured in meter per second. This is the SI unit. So both of them, they are going to have units as meter per second. Time is measured in seconds. So SI unit of time is second. Make sure this time is the time between the V and the U. Now by this example we are going to understand what is T, because that is what is the most crucial part of the entire explanation. Here this case is very simple, and for example I take up any two vehicles for calculation of the acceleration. Let me consider one as this vehicle and another is this vehicle. You can consider any of those vehicles out of these all vehicles which are given to you. Now the vehicle which is at lower time, at less time, its speed is considered as U, and the vehicle having some speed at a larger time, that is considered to be as V. Now the time T which is shown over here is the time gap between these two values, this one and this one. So basically this time T is the time taken by the car to go from U to V. So we are talking about this time difference. So this T is nothing but the time taken in between V and U. That is time taken by the car to go from U to V. So here if you put all the values, you will get A is equal to V, that is 8 meter per second, minus 4 meter per second, upon 4 minus 2, so that is 2 seconds. Now 8 minus 4 is 4, meter per second is not cancelled. We are actually pulling this meter per second outside, we are taking it common, so 2 seconds. 2 ones are 2 twos are, this second and this second are going to get multiplied and it will be 2 meter per second square. Now on the other hand you can also write down this 2 meter per second square like this, 2 meter per second upon 1 second, because anyhow 2 by 1 is 2, meter per second square is same as meter per second square. So you can say that after every second the speed of the car increases by 2 meter per second. So 2 meter per second square is the acceleration of the car. So 2 meter per second square means after every 1 second there is an addition of 2 meter per second in the velocity, which is very clearly shown over here. So if there is an addition of 2 meter per second after 1 second, the acceleration is 2 meter per second square. This is a very easy situation because I have considered equal gap in the speeds. If the speeds are not, at a constant interval, then you will have to calculate the acceleration for different cases. If you want to plot the graph of v versus t, then time is to be always plotted on x-axis because it is an independent quantity, and speed is always plotted on y-axis. This is x-axis. And you will see that as time passes, the speed of the car is also increasing, so you will get a straight line graph passing through the origin, because this point is 0, 0, and at time is equal to 0, the car was having speed 0. So here you can always say that the car is accelerating because there is an increase in the speed after every 1 second. And that increase in the speed after 1 second, that value is only called acceleration. Its unit is meter per second square. So acceleration is written in meter per second square. Another thing, it is a vector quantity. Vector quantity means it has got a direction. Now, you might wonder that in which direction is the acceleration. So acceleration being a vector quantity has got some direction. Now, the direction of acceleration is always the direction of increase in the speed or increase in the velocity. Here, the velocity is increasing in this direction, so this is the direction of acceleration. Acceleration always comes in picture when there is a force acting on the body. Here we are not going to go in much of the depth, but you should always remember that whenever there is a force, there has to be an acceleration. Let us understand acceleration due to gravity now. Suppose there is a very tall building and there is a boy standing over here with a ball in his hand. This ball, or suppose this is a stone. Now this stone is at rest because it is in the hand of this person, so its speed is 0 meter per second. And suppose the boy leaves, the boy is not throwing the stone, he is simply leaving the stone. So the moment you leave, the time starts, so at that time, time is 0, and at that time speed was 0, then the speed will keep on increasing. Acceleration due to gravity more precisely is taken as 9.8 meter per second square. You can also consider in some cases as 10 meter per second square, as this makes our job very easy, right? So that means if I consider this 10 meter per second square as acceleration due to gravity, that is g. So g is acceleration due to the gravitational force acting on the stone in this direction. So that means the direction of force is this, the direction of increase in the velocity is this, and the direction of acceleration thus would be in the downward direction. So this is the stone after time is equal to 1 second. This is the stone at time is equal to 2 seconds. And let us assume this is the stone at time is equal to 3 seconds and it touches the ground at 3rd second. Now, this means you can also write it down as 10 meter per second upon 1 second, as we have discussed the concept of acceleration here, that you can write down 2 meter per second square as 2 meter per second upon 1 second. In the same way, you can also write down 10 meter per second square as 10 meter per second upon 1 second. That means after every 1 second, the stone gains speed by 10 meter per second. So it was 0, there will be an addition of 10 meter per second. So here the stone speed will be 10 meter per second. Again after 1 second, there will be an addition of 10 meter per second, so 20 meter per second. And again after 1 second, there will be an addition of 10 meter per second, so it is 30 meter per second. So when the stone touches the ground, at that point, it has got highest speed and it will have highest kinetic energy as well. Now, this acceleration due to gravity is coming from the formula Gm upon r square. Now, this is the mass of the earth. This is the radius of the earth. And this is the universal constant of gravitation. So, you will probably learn about these things in grade 9 and grade 11. So we have actually discussed about the acceleration in nutshell, and hopefully you have enjoyed my explanation as well.